Translate some expressions today in class. Our lesson today. Our learning target is students can write a real-world situations as mathematical expressions. So we're going to take what we say in words and we're going to write it mathematically. So we're going to go over some key words and phrases that you need to know about. So translating expressions. If you need to pause, go ahead. Otherwise, I'm going to move on to my first slide. Okay. In our first example, we're just going to be translating models. So each of these cubes are going to kind of represent a positive 1. If there was a negative sign in them, they would represent negatives. But we're not going to worry about that right now. So my first example, all you're going to do, the most simplified one is the easiest one to look for. So I have 6 pluses, so that's 6. And then I have 2 that have x's in them. So plus 2 x's. And that's the most simplified answer. Now what you might get is equivalent expressions that represent 6 and 2x. For example, I could have an equivalent expression of 6 plus, well I have 2 x's, so that'd be x and x. So I have 2 of them, so notice I have 1, 2 when I add them together. I could even break up the number. I could have 4 plus 2 plus 2x. Okay, so what you need to do in all these equivalent expressions, the first one being the most simplified of my answers, is as long as whatever I have written, okay, adds up to 6 as far as the numbers, my little squares, and then my x's add up to 2x's, so if I separate them, then I have the right answer. Okay, so for B, I have 3 pluses, so that's 3, and then I have 5 x's plus 5x. So that would be the simplified answer. But equivalent expressions, other ways of writing this, I could have 3 plus 2x plus 2x plus x. 2 plus 2 plus 1x. So I have 2x's plus 2x's is 4x plus 1x is 5x. So those are just different ways I could write equivalent expressions. If I ask you to write it, for the most part you're going to give me the simplified form, but if it's a multiple choice you may have to be able to recognize other forms. Okay? If you need to pause, go ahead, and otherwise I am moving on to my next slide. Right, in example 2, translating situations. So now I'm just giving you situations. The first example is pretty straightforward, and then the second example is a little more of a word problem. All you're going to do is write these as mathematical expressions. So 24 less than S students. Now this one's key. Less than is a very interesting phrase. The word than actually switches the order in which you write the numbers or variables that are in the problem. So normally you would go left to right like you're reading, but when I say less than, then that means that the end part is the starting amount, and then the beginning part, the 24, that's what happened to it. So in this case I have 24 less than, and than is being that key word. When you see than, that's going to clue you in that you need to switch the order of the number and the variable, or the numbers and the variables in the problem. So 24 less than S students is actually going to be S minus 24. Okay, and that's an S minus 24. Okay, if you write 24 minus S, that would be incorrect. Okay, so if you were to think of a number for S like 50 students, if I have 24 less than 50 students, you would do 50 minus 24. Okay, so you have to know that word than is very important. Okay, and that switches the order. Otherwise, you typically write left to right. Okay, in example B, Trey gives himself and each of his 5 friends C cookies. He has 2 left over. Okay, well if I give someone 5 cookies and I have 10 friends, I'm going to multiply 5 times however many friends I have. In this case, you have Trey and 5 friends. So you have Trey plus 5 friends. So that's 6 people. So you could do 6C, okay, and that's 6 times the number of cookies. Now he has 2 left over, so that's going to be plus 2 because there's an additional 2 left over. Okay, another way you could think of this problem is you could say, well, Trey's getting some cookies, plus his 5 friends are getting some cookies, and then he gets 2 left over. That would be an equivalent expression. Now look at that. I have 1C and I have 5C, Trey and 5 friends. There's my 6C. So you can see it's added together or you can see it's separated. Either one would be fine depending on how you viewed the question. Okay? So that's example 2. If you need to pause, go ahead. Otherwise, I'm moving on to my last example. In example 3, writing real-world situations. Now it's going to be the opposite. I'm going to give you the mathematical expression. You are going to give me the real-world application. So the first example, I'm just going to do some basic ones, just using math terms and not very, I say not very interesting, just very mathematical. So if I said something like R increased by 14. Okay? I'm adding, increased would be one for adding. I could do R plus 14. Okay, and that would be another one I could do. If I wanted to switch it up, I could do 14 more than, there's that key word, than R. If I really wanted to get crazy, I could make something like 14 more than R rabbits. That could make it a little bit more interesting. Okay, and those are just basic ones. All right, now, if you want to write a word problem situation, then you put some sense to it. So let's say for B, I have D divided by 4. Okay, so I could put something like the quotient of D and 4, because remember quotient stands for division, or I could put D divided by 4, or I could make it more like a word problem. A bill costs D dollars. Okay, so there's my D, all right, and then I could say it is split equally among 4 people. Well, splitting something equally, that's division, so that would be my D, the cost, divided by the 4 people that are equally splitting it, so D divided by 4, or the quotient of D and 4. Okay, so that's how you write those situations. Just to go over some that you need to remember, okay, remember sum is adding. I'll write these off to the side. Sum, remember, is adding. Difference, you might want to write these down, is subtracting. Product, again, remember, is multiplication. And quotient, that's division. So if you see or want to use those words, okay, that's what they stand for in those contexts. Okay? Alright, so like for A, I could have done the sum of R and 14. For B, I could have done the quotient of D and 4. Alright, so that's our video today. If you need to go back and watch anything, go ahead. Otherwise, I will see you guys tomorrow.